One thing that we want to be able to do is to find domain algebraically. So we won't always have the graph. Sometimes we'll just have the equation. You'll notice that the title says to find the domain. It doesn't say to find the range, because there's really not a good soundproof process for finding the range algebraically. So instead, we're just going to focus on the domain. So the guiding question when looking for domain algebraically, and excuse me, I'm sorry, ignore this photo, this shouldn't be here. Your guiding question is, what is not allowed? What values do I not want to occur? So there's a few different scenarios that can happen. For example, let's say I'm looking at a linear equation. I want to think about a line and what values cannot occur on a line. Well, there really isn't anything. All numbers work. I can plug in any value I want and get a response. So every input has an output. That means that the domain of a linear function is always all real numbers. That will always be the case. When I look at a fraction and I think about what's not allowed in a fraction, I know that my denominator is not allowed to equal 0. Any other number is fine. Radicals, fractions, decimals, any value I want to plug in for that x is totally okay. But if there's a number in there that makes that denominator equal 0, that's going to cause an issue. So what I'm going to want to do is figure out what number is bad. So I'm going to set the denominator equal to 0 and solve, and I get 3. That is a bad value. Therefore, my domain is all the numbers except 3. Notice I'm not including 3, but everything else is allowed. Another scenario that can occur are square roots. Think about what values you don't want in square roots. You don't want negative values. That causes an issue. Whether you have nice pretty numbers or you have decimals, all of those you can solve. But as soon as you bring in that negative, you have an issue. So, similar to how we did fractions, we're going to take the inside and we're going to say, all right, I want to find all the values that are going to make this thing be negative. Now you got to ask yourself, are you allowed to equal 0? Is 0 an okay number? It is. You can have the square root of 0. As you see, the square root of 0 equals 0. So I just want to figure out all the values that are less than 0. Remember, these are your bad values. So when I solve that, I get x is less than negative 5. Again, remember that's all of the bad values. So the domain is going to be everything that is bigger than negative 5. So I'm going to put negative 5 not included all the way to infinity. So remember, we're doing the opposite of this thing, right? The domain is the opposite. Excuse me. All right. And in the solution, I don't want to confuse you. I actually did it different. So if you notice the way that I put my inequality sign a second ago, right here I have it less than 0 because I was finding the bad values. In the solution, I have it greater than or equal to 0. That's because in this solution, I'm solving for the okay values. You truly can pick which one you prefer and which one makes more sense to you. Either one. If you want to solve for the bad values and do the opposite, or if you just want to go straight forward and solve for the good values, that's fine too. All right, looking at these examples, I want to find the domain. Looking at these examples, I want to find the domain. Right here in this first problem, I have a fraction, and I know that I cannot have 0 on the denominator. So I'm going to set that denominator equal to 0 and solve, and that represents a value that's not allowed. Therefore, the domain of this function is all numbers except for negative 7. When I look at problem number 2, I see that I have a radical. I'm going to solve for the values that are okay. So I'm going to set just the inside, 7 minus 8x, to all the values that are bigger than or equal to 0, and those are going to represent the good values. And I'm going to begin solving, and I'm going to have to flip my sign because I'm dividing by a negative. And again, these are the values that are allowed, therefore the domain is negative infinity to 7 over 8. 7 over 8 is included. When I look at my next problem, I have 3 minus x. Again, this is an inequality problem. I'm going to set it greater than or equal to 0. These represent the good values, and begin to solve. Flip my sign because I'm dividing by a negative. Therefore, the domain is negative infinity up until 3, and 3 is included. Looking at my next problem, I have a fraction, so I'm going to set that denominator equal to 0. That's going to give me 3 halves is equal to x. Remember, this is a bad value, therefore the domain is all real numbers except for 3 halves. And in my very last function, this one's a little different because I decided to do a combination of 2 things. Oh wait, no I didn't, I'm seeing things. I'm sorry about that. So instead, I decided to bring in a quadratic. So thinking back to your other section, you know that x squared minus 4 is x plus 2 as well as x minus 2. And that produces the solutions negative 2 and the solutions positive 2. Therefore, the domain is all numbers except for those values. So negative infinity to negative 2, negative 2 to 2, 2 to infinity. And I apologize for Bento barking in the background. You guys know, as soon as I start making a video, he loves attention. I hope you found this video helpful. As always, if you have questions or concerns, please don't hesitate to reach out.